All right, so let's take a look at Unit 4A review, okay? For the first page of our review, it says, provide the name of each part of the circle using the image in the word bank. Words can be used more than once. All right, so let's start by looking at number 1, which is segment LE. Okay. Segment LE has 2 points on the circle and it goes through the center, which tells us that segment LE is the diameter of circle F. Okay. Segment FG starts at the center of the circle and goes to a point on the circle. By definition, line segment FG is a radius of circle F. Line EJ starts at point E, goes through point F, goes through point L, and goes outside the circle, okay? By definition, when we're talking about our parts of a circle, we have 2 lines, okay? One is the secant and one is the tangent. Look, this line intersects your circle at point E and point L, which tells us that line EJ is a secant. Okay. Number 4 asks us what type of angle would closely define angle EFG. Okay, look, angle EFG, the center is at point F, or sorry, the vertex is at point F, which tells us that angle EFG is what we call a central angle. Okay. Number 5 asks, how would we describe angle EHG? So here we go, our angle that's highlighted in purple, okay? Look at it, the vertex, which is at point H of this angle, is on the circle. So by definition, angle EHG is an inscribed angle. Okay. Segment HG starts at point H, goes through the circle and stops at point G, okay? Segment HG is a chord. Be careful, the most common incorrect answer for number 6 is a diameter. Remember, the diameter is a chord, but it's a special chord that goes through the center of the circle. Okay, look, segment HG does not go through the center of the circle. The center of the circle is at point F. So that tells us that segment HG is simply a chord in our circle. Okay, line KM. Line KM. That's this line right here. Okay. Line KM, it intersects the circle at exactly 1 point. So by definition, line KM is a tangent, okay? Let's look at line segment EF, number 8. EF. Okay, look. Point F is at the center and point E is at the circle, which tells us that segment EF is another radius in our circle, okay? What about segment EH? EH. We start at point E, go all the way up to point H, okay? It is inside of the circle. It has point E where it starts and point H where it stops, which tells us that segment EH is a chord, okay? Again, the most common incorrect answer that I see that people use to describe line segment EH is the diameter. But be careful, EH, it is a chord, but it does not go through the center. So it's not a diameter, it's just a chord, okay? Line MJ, okay? Here is line MJ. Okay, look, line MJ touches the circle at exactly one point, which is point M, which means that line NJ is a tangent, okay? Because by definition, a tangent intersects the circle at exactly one point. All right, let's go to number 11 and look at arc MH, okay? There's arc MH, and we know it has a measure of 15 degrees. Since the measure of arc MH is less than 180 degrees, then we automatically know that arc MH is a minor arc. Okay. Next, they ask you about arc EML. Okay. Y'all look, it starts at point E, it goes all the way around to point L, which creates a semicircle. So arc EML is a semicircle. All right, let's look at arc number 13, arc EMG, okay? Y'all look, if we know EML is a semicircle and LG goes past that, we know that that has to be a major arc, okay? Because by definition, a major arc is greater than 180 degrees. Number 14, they asked us about arc EG. Arc EG. Okay, we know that because central angle EFG goes with arc EG, that the measure of arc EG is 125. Okay, because that is our formula or definition. Central angles and their intersected arcs have the same measure, AKA they're congruent. So since we know that the measure of arc EG is 125, we also know that arc EG is a minor arc because it has a measure that's less than 180 degrees, okay? Now, question 15 asks us to name the arc that goes with angle EFG. And we just named it in the last problem. The minor arc that goes with angle angle EFG is arc EG, okay? On the converse for number 16, they asked us to name the major arc that goes with angle EFG. So same angle, but this time we're looking for the major arc instead of the minor arc. Y'all look, if the minor arc is down here, the major arc is this part of the arc that's all the way around the outside, okay? So we could call it arc EMG. We could call it arc EHG. We We could call it arc ELG. We're still talking about the same major arc. Okay. Number 17, by definition, the major of a minor arc is less than 180. The measure of a major arc is greater than 180. Let's move over to the second page of your review. All right, so for all of the problems in the top part, we're asked to find the measure of the indicated arc or angle, okay? So for number 17, they asked us to find the measure of arc BC. Okay. But what we do know is that the measure of central angle BOC is 132. Okay. By definition, the measure of a central angle and its intersected arc are congruent. Hence, the measure of arc BC is also 132. Okay. For number 18, they asked us to find the measure of arc BAC. Okay. Y'all, it's 3 letters. So you already know either it's going to be a semicircle, which is exactly 180, or it's going to be greater than 360, okay, because it's a major arc. Now, to find the measure of arc BAC, we know that the measure of arc BC is 132, and we know that the sum of all the arcs in the circle are 360. So we can just take 360 and subtract 132. Okay. And this helps us determine that the measure of arc BAC is 228. Okay, number 19, they asked us to find the measure of arc EG. Okay, y'all, here is arc EG. All right, so let's start out by looking at the information that they give us. Okay, we know this central angle CAD has a measure of 90 degrees, which means that arc CD has a measure of 90 degrees, okay? Y'all, if I look, okay, I notice that CF is the diameter in the circle, which means this creates a semicircle, okay? Look, on arc DE and EF, we have 2 tick marks, and those 2 tick marks, remember, tell us that the measure of those 2 arcs are congruent. So look, if arc CD is 90 degrees and arc CDF is a semicircle, we can take 180 and subtract 90, which leaves us with 90, okay? Which tells us that the measure of arc DE and EF is also, they also have a sum of 90 degrees. Since these 2 arcs are congruent to each other, simply divide them by 2 to find the measure of each arc, okay? So now we know that the measure of arc DE and EF is 45, and now we can solve our problem, okay? Remember, we're trying to find the measure of arc, the arc that's highlighted in yellow. Remember, we're trying to find the measure of arc EG, okay? So look, we have the measure of arc EF, it's 45, but we still need to find the measure of arc FG. Y'all look, if the measure of central angle FAG is 5, then that means the measure of arc FG is 5. Y'all, 45 plus 5 is 50. So the measure of arc EG is simply 50. Let's scroll down and look at problems 20 through 22. Okay. On problem number 20, they asked us to find the measure of angle EBF. Okay. What they do tell us is that the measure of angle ABF is 20, and that the measure of angle DBE is 90. Okay. Look, this creates, since DA is the diameter, this creates a semicircle, which means if the measure of this angle is 90, central angle is 90, this central angle is 20, but all of these central angles added together have a sum of 180. We can do 180, 90 plus 20 is 110, minus 110, and we're able to figure out that the measure of angle EBF is 70 degrees, okay? Number 21 asks us to find the measure of angle CAP. Y'all hear central angle CAP, okay? Now, what some of you would try to do is you would recognize that CD is the diameter of your circle, and you would try to use the fact that from CAD, arc CAD is a semicircle, okay? But look, you don't know the measure of arc AD or CB, so you couldn't use that particular method, okay? But look, angle CPA and angle BPD are congruent angles, okay? So to solve for X and find the measure of CPA, we could simply take the measure of the two angles, which in one case is 4X minus 5, and set it equal to 2X plus 65. We got to combine like terms, because remember, we can't have variables on both sides when we're trying to solve. Remember, when we're trying to solve equation, our objective is to isolate the variable. So you have 2X minus 5 is equal to 65, okay? Remember, we're solving for X, so still our position is this. We want to do everything that we can to isolate the variable. Right now, 2X is being subtracted by 5. So to undo that, we have to add 5 to both sides, okay? Bring down our 2X, bring down our equal sign. 65 plus 5 is 70. Okay, we're almost there. X is almost isolated. Last step is to divide both sides by 2, because X is currently being multiplied by 2, and 70 divided by 2 is 35, okay? Some of y'all have a tendency to stop here, but look, your original problem, it did not ask you to find the value of X. It asked you to find the measure of angle CPA, okay? The current measure of angle CPA is 4X minus 5. Since we know that X equals 35, we simply substitute 4 times 35 minus 5. Y'all, 4 times 35 is 140, minus 5 is 135, which tells us that the measure of angle CPA is 135, okay? It's 135. All right, let's slide over to number 22. On number 22, they asked us to find the measure of the indicated angle, okay? We're trying to find the measure of angle PRQ, okay? But in order for us to find the measure of that angle, we first have to find the measure of its intercepted arc, okay? The arc that goes along with that angle is PQ, and we currently know that arc PQ has a measure of 3x plus 1, okay? Right now, that is not enough information to help us solve our problem, so we can't just use the measure of arc PQ, okay? We have to do something else first. Maybe solve for x first. And I think if we solve for x, that would help us figure out how to calculate the measure of angle PRQ, okay? So look. Arc PQR creates a semicircle, okay? Because PR is the diameter. We already know that the measure of arc PQ is currently 3x plus 1, and we know that the current measure of arc QR is 7x minus 1. Y'all, since arc PQR is a semicircle, we can take (3x plus 1 plus 7x minus 1) and set it equal to 180, because we know that our PQR is a semicircle, okay? We got to combine like terms. 3x plus 7x is 10x, okay? Positive 1 minus 1 is 0. So on the left side, we're left with 10x, and it's equal to 180, okay? Last step is to divide both sides by 10, which tells us that x equals 18, okay? Remember, you can't stop here because they didn't ask you the value of x in the problem. They asked us to find the measure of the indicated angle, okay? Y'all, if we know that x is equal to 18, then to find the measure of our PQ, we take 3, since PQ is currently 3x plus 1, we take 3 and multiply it by 18 and add 1 to find the actual measure of the arc, okay? 3 times 18 is 54, plus 1 is 55, okay? So now we know that the measure of arc PQ is 55, okay? We know that the measure of arc PQ is 55, but that's still not what we're trying to answer. They ask us to find the measure of angle R, okay? So now look, here's angle R, and here is the arc that goes with the PQ. And we know PQ has a measure of 55 degrees. Y'all look, the vertex of angle PRQ is on the circle, so we automatically know that that is an inscribed angle. By definition, to find the measure of an inscribed angle, we take the measure of the arc and divide it by 2, okay? So 55 divided by 2 is 27.5, which means that the measure of angle R is simply 27.5. All right, let's move on to the next page of your review. All right, so number 23 says, if point O is the center of the circle, find the measure of arc AB, okay? So ultimately what we're trying to find is the measure of arc AB, okay? Y'all look, we have no information about central angle AOB, so we couldn't use central angle AOB to help us find the measure of arc AB, okay? We have to use something else. So at first glance, you notice the measure of angle A is 27 degrees. okay? So look, at the vertex of angle A, it is on the circle, which tells us that angle A is an inscribed angle, okay? We know the measure of angle A is 27 degrees. So let's use that to help us at least figure out what the measure of arc BC is, because arc BC will help us figure out what the measure of arc AB is, okay? Remember, according to our definition of inscribed angles and their intercepted arcs, okay, our inscribed angle has a measure of 27 degrees. So we take 27 degrees and multiply it by 2 to find the measure of arc BC. 27 times 2 is 54, which lets us know that the measure of arc BC is 54, okay? But Ms. Grubbs, that still does not quite tell us what the measure of arc AB is. Yes, I understand that, but you still have enough information to find the measure of arc AB, okay? Y'all look, AC is the diameter in circle O, which tells us that arc ABC is a semicircle. We know that a semicircle has a measure of exactly 180 degrees. So we can take 180 and subtract 54, and that will give us the measure of arc AB. So 180 minus 54 is 126. And that tells us that the measure of arc AB is 126. Y'all, when we were going over the lesson about inscribed angles and their arcs and central angles and their arcs, I reminded you all then, use the diameter of your circle to figure out where your semicircles are. A lot of times that will help you solve your problem if you're trying to find either the measure of an inscribed angle, a central angle, or an arc that goes with, either one of those types of angles, okay? Number 24 asks us to find the measure of arc angle, y'all, angle. It asks us to find the measure of angle BAC, okay? Asks us to find the measure of BAC. The only thing that we know right now about circle O is that the measure of central angle COD is 94, okay? We're going to use that to help us solve our problem, okay? If the measure of central angle COD is 94, and remember, arc CD is this intercepted arc, or the arc that goes with that central angle, then the measure of arc CD is 94 because the definition says that central angles and their arcs are congruent, okay? But Ms. Gross, that's still not getting us to the measure of angle BAC, okay? Well, we're almost there. Okay, look, arc BC is the intercepted arc for our inscribed angle BAC, okay? Y'all, again, BD is the diameter of your circle. So look, yet again, this creates a semicircle. We know that the measure of a semicircle is 180. So we're going to take 180, subtract 94. Okay, which gives us 86. So we now know the measure of arc BC is 86. But remember, our question did not ask us to find the measure of arc BC. It asked us to find the measure of angle BAC. Since this is an inscribed angle, our definitions for inscribed angle says to take the measure of its intercepted arc and divide it by 2, okay? 86 divided by 2 is 43. So the measure of inscribed angle BAC, or just angle A, is 43 degrees. All right, let's slide on to question number 25. Okay, 25 asks us to find the value of x. What your diagram has highlighted is they're telling us that this angle right here has a measure of 3x, and this angle right here has a measure of 2x plus 3, okay? Y'all look, both of these angles are inscribed because their vertices or their vertex is on the circle, okay? Y'all look, this is the common arc that they share, okay? Because those two inscribed angles share the exact same arc, then we automatically know that these two inscribed angles would also have the same measure, AKA they're congruent to each other. So to solve for x, we just take 3x and set it equal to 2x plus 13. Okay, remember, we're trying to isolate the variable because we're solving for x. Subtract 2x from both sides, because remember, our objective is to isolate the variable. That reduces to 0. 3x minus 2x is just x. Bring down our equal sign, bring down our 13, which tells us that x equals 13, okay? This time we can stop there because look, they just asked us to find the value of x, okay? They didn't ask us to find the measure of the angle. Y'all, if they did ask us to find the measure of the angle, just take the value of x, which is 13, and multiply it by 3, okay? And that would give you the measure of your angle. All right, let's go down to number 26. It's another problem where it asks you to find the value of x. So look, I'm going to take a second to highlight the angle that I'm finding the measure of, okay? Angle MDE, or we could just say angle D. Okay, look, since angle D, the vertex of angle D is on the circle, we know that it's an inscribed angle, okay? In order to find that measure of that inscribed angle, we know already that we have to find the measure of its intercepted arc, AKA the arc that goes with that angle, okay? Some of y'all are like, Ms. Grubbs, how can we find the measure of that arc? It's not enough information given. Well, look, your diagram tells you that the measure of arc MD is 80 degrees and the measure of arc ED is 74 degrees. Remember, our definition of arcs in an angle, arcs in a circle tells us that all the arcs in a circle add together to 360 degrees. So we can simply take 360 degrees, subtract 80 plus 74, which is 154. And that's going to give us the measure of arc ME. Okay. 360 minus 54 is 206. So we know that the measure of arc ME is 206. By definition, the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So just take the 206 and divide it by 2, okay? 206 divided by 2 is 103. So the measure of angle MDE is simply 103. Okay, for number 27, they asked us to find the measure of angle J and the measure of angle K. Okay, right here we have a quadrilateral. Look, 1, 2, 3, 4 sides. 1, 2, 3, 4. Okay, sides. We have a quadrilateral inscribed inside of a circle. According to our definition, the opposite angles M and K in a quadrilateral always are supplementary, which means the two angles added together have a sum of 180. So if we know that the measure of angle M is 45, and we know that the sum of angle K and angle M has to equal 180, then we just take 180 and subtract 45, And that tells us that the measure of angle K is 135, okay? Now, to find the measure of angle J, now again, same rule applies. They're opposite angles in a quadrilateral. The sum of those two angles equals 180 because by definition of quadrilaterals that are inscribed inside a circle, opposite angles are supplementary, which means they have a sum of 180. So to find the measure of angle J, do 180 minus 92, okay? Which means that the measure of angle J is 88 degrees, okay? Y'all, that's it. That just goes back to one of our definitions. All right, number 28, okay? It asks us to find the measure of the missing angle. In this case, it is angle L, okay? The first thing that we have to ask ourselves is, where is the vertex of the angle, okay? We can clearly see that the vertex of the angle is outside the circle. Since it's outside the circle, we know that we have to use the formula larger arc minus smaller arc divided by 2 to find the measure of our angle. Okay. So look, we're trying to find the measure of angle L. It's outside. The measure of our larger arc, JV, is 127 minus our smaller arc, KM, which is 47. And then we divide by 2. 127 minus 47 is 80. And then 80 divided by 2 is 40. So the measure of angle L is 40 degrees, okay? Look here, number 29. We're dealing with another angle whose vertex is outside the circle, okay? So we're gonna use the same formula, larger arc minus smaller arc divided by 2. But some of y'all like, Miss Grubbs, we only know the measure of the smaller arc. We know that the smaller arc has a measure of 45 degrees, okay? You're absolutely correct. Y'all, here's your smaller arc right here. Look, we have to figure out the measure of our larger arc on this side, okay? If you know that the small part of your arc is 45 degrees, and you know that the sum of all arcs in a circle is 360, so to find the measure of your larger arc, just take 360 and subtract 45 degrees. And you'll be able to determine that the measure of your larger arc is 315 degrees. So we're going to do 315 minus 45 divided by 2. 315 minus 45 is 270. And then 270 divided by 2 is 135, okay? So the value of X, AKA the measure of your angle with the vertex that's outside is 135. All right, let's go to the last page, okay? This is where we're going to start dealing with segments, chords in a circle, and angles that are created when two chords in a circle intersect, okay? Y'all, what they asked us to find the measure of is this angle right here, okay? Look, the vertex of this angle is inside the circle, okay? What people commonly want to misunderstand is they want to say that this angle that I have highlighted in blue is a central angle, but it's not. Y'all look at the vertex. It's not on the center. The vertex is up here. The center is right here, okay? So the vertex of the angle is inside. So we need to use our formula to find the measure of an angle when the vertex is inside. Our formula tells us we do arc plus arc divided by 2 to find the measure of an angle that has a vertex inside the circle, okay? So look, the measure of this larger arc is 129, and the measure of the smaller arc is 17. So we do 129 plus 71 divided by 2, okay? Divided by 2. Y'all, 129 plus 71 is 200, and then 200 divided by 2 is 100, which tells us that the measure of the angle here where you see X is 100, okay? Over here with number 31, we clearly see that the measure of arc ED is 164. What we're trying to figure out is the measure of arc FT, okay? Look, they give us the measure of an angle. They give us the measure of angle ECD, okay? So look, the vertex of the angle is inside, so we're still using arc plus arc divided by 2 because the vertex of the angle is inside, okay? Y'all look, the arc is what we're missing this time. So we're gonna say, let's just use X as our variable. Okay, let's call, instead of question mark, let's just call it X. So X, because that's the measure of our arc that's unknown, plus 164 divided by 2. And remember, our angle this time is 120 degrees. Okay. Look, we're trying to solve for X, but look, it's a lot of stuff going on with X. First thing we do is multiply both sides by 2, because we don't want to have to deal with this in variable form. When we multiply both sides by 2, 2 times 120 is 240. That just makes these two reduce. It's equal to X plus 164. Divide both sides by 164. And that tells us that the measure of arc FT is 76, okay? Y'all, please make sure that you understand if the vertex of your angle is inside the circle or outside the circle, okay? Because that makes a huge difference on how you solve your problem. Let's mosey on down to number 32, okay? Look, we have 2 chords inside of a circle, and what they want us to do is find the value of X, okay? So look, we have to look at the 2 chords separately. Okay, here's our chord in green. One part of the chord is 6. The other part of our chord is X. So 6 times X, because remember, when we have 2 chords in a circle, it's one segment of the chord times the other segment of the chord is equal to one segment of the chord times the other segment of the chord, which is equal to 3 times 4, okay? 6 times X is gonna give us 6X. 3 times 4 is 12. So we got 6X is equal to 12. We know to divide both sides by 6, and X equals 2, okay? Here, we're following the same, exact same premise because we have two chords in the circle, okay? We have two chords in the circle. That segment of the chord has a value of X, and this segment of your chord has a value of 12, okay? So X times 12 is equal to, remember, it's equal to the two other segments in your chord. This part of the segment is 6 times, and the other part of that segment is X plus 4. So look, y'all, please be careful, because here you have to multiply 6 times X plus 4. And what I just noticed in the past is that some people just want to multiply either X times 6 or 4 times 6, but you have to multiply the entire part of this segment since it's X plus 4. Okay, X times 12 is 12X. Bring down our equal sign. We have to distribute this 6. So we get 6X plus 24. Okay. All right, we have variables on both sides. We don't want that. Remember, when we solve equations, our objective is to isolate the variable. So we're going to subtract 6X from both sides. 12X minus 6X is 6X. Bring down an equal sign, bring down your 24. Okay. Last step, X is being multiplied by 6. So we divide both sides by 6. And now we know that X is equal to 4. Okay. And we stop there. Y'all remember, when you see two chords inside of a circle and they're asking you to find the length of one of the segments of the chord, remember, it's the segment of the chord times the segment of the chord equal to the other segment of the chord times the other segment of the chord, okay? That's based on your chords theorem that were in your notes from last week. All right, let's go on over to 34, okay? 34, y'all, before we try to solve this problem, we need to look at the lines or line segments that you see that are in that circle, okay? Look, this top line intersects the circle at 2 points, right here and right here, as does this bottom line. It intersects the circle twice, okay? This tells us that we're dealing with two secants, okay? Two secants. Our formula for two secants says the external part of the secant, so look, the external part of our top secant is 6 times the length of our entire secant. The length of our entire secant is 6 plus 4. Okay, let's slide down to the secant on the bottom. The length of the exterior part of our secant is 5, and the length of our entire secant is 5 plus X. Because we don't know what X is just yet. That's what we're solving for. Okay, we do have to distribute. 6 times 6 is 36, and 6 times 4 is 24. Bring down our equal sign. 5 times 5 is 25. 5 times X is 5X, okay? Y'all look, on the left-hand side, we have 36 plus 24. We can add them together and that's 60. So we have 60 is equal to 25 plus 5X, okay? Remember, we're solving for X and our objective is to always isolate the variable. So look, because 25 is being added to X, we can subtract it from both sides, okay? 60 minus 25 is 35. Bring down your equal sign. This reduces. Then bring down your 5X, okay? Last step here, since X is being multiplied by 5, we divide both sides by 5, and X is equal to 7. Okay. All right, let's look at number 35, number 36, and number 37 so we can get this wrapped up. okay? Number 35, okay? Again, we have to look to see what type of lines or line segments we have. So let's look at the top one. Y'all, the top line in blue, it only intersects your circle once, so that is a tangent, okay? Whereas the bottom line that is in yellow, it intersects the circle at 2 points, here and here, which means that that is a secant, okay? Which means we're gonna have to use our formula for tangent secant segments. Have to use our formula for tangent secant, okay? What our formula for tangent secant tells us is that we take the length of the tangent, which in this case is x, and set it equal to the external part of our secant, which is 9, times the length of our entire secant, which is 9 plus 7. Okay, we bring down our x squared. Y'all, 9 times 9 is 81. 9 times 7 is 63. Okay, because we had to distribute. Y'all, when we add 81 plus 63 together, we get x squared is equal to 144. Okay, y'all, it's mathematically impossible for x to have a value of 144. Look, plus x is squared, which tells us to unsquare square, we have to take the square root of both sides. The square root of x squared is simply x, and the square root of 144 is 12. And that's how we were able to determine that x is 12, aka the length of our tangent in this case is 12. Okay. With number 36, they asked us to find the length of JM. Okay. Right now, we don't have enough information to find the length of JM. But we do know that JM and JK are both tangents because both of them intersect the circle at exactly 1 point. Here at point K and here at point M, okay? So to solve for X, because we know this is a party hat and two tangents are congruent or equal to each other when we see a party hat, to solve for X, we just take the lengths of the segments right now, which are 2x plus 2 and 5x minus 4, and set them equal to each other. Okay. Y'all remember, objective, isolate the variable. We subtract 2x from both sides just to keep our variable positive. This reduces, bring down our 2, bring down our equal sign, bring down our 3x, bring down our -4, okay? Remember, our objective is to isolate x. Right now, 3x is being subtracted by 4, so we want to add 4 to both sides. This reduces, 2 plus 4 is 6, bring down our equal sign, bring down our 3x, okay? Remember, we're trying to isolate the variable, so since x is being multiplied by 3, we divide both sides by 3, and x is equal to 2. But you can't stop there because look, they asked us to find the length of JM, not the value of x, the length of JM. Since JM is currently 2x plus 2, 2, we know that x has a value of 2, so 2 times 2 plus 2. 2 times 2 is 4 plus 2 is 6, so the length of JM is 6, okay? All right, number 37, okay? That is our very last one, okay? We have two chords. We have two chords. We have two chords. And by definition, the distance from two congruent chords is exactly the same distance from the center to a point on the chord, okay? Which tells us that GF and EF are congruent. So to solve for X, we take the length of EF, which is 3X, and GF, which is 7X minus 8, and we set them equal to each other to solve for X, okay? Y'all, we're gonna have to subtract 7x from both sides. I usually tell you all to subtract the term with the higher coefficient for your variable, but in this case, that's not gonna work for us because that's gonna make the left side 0. So we're gonna have to subtract 7x from both sides. Y'all, 3x minus 7x is -4. Bring down an equal sign. This reduces to 0. Bring down your -8. Y'all, look, be careful right here. X is being multiplied by -4. So we have to divide both sides by -4. Y'all, -8 divided by -4 is 2. So that tells us that x is equal to 2. Y'all, but look, they asked us to find FE. Since FE currently has a length of 3, 3 times 2 is 6. So we know that FE has a length of 6. Now, what I have noticed is that some of you have been a bit unfocused while we were going through the different angles and the different segments. That's why I gave you 4 different opportunities to practice each concept. But some of you did not actively practice, so now we're sliding into test day tomorrow, and some of y'all are struggling. My advice to you is to make sure you work through these problems on your own by yourself to make sure you have a clear understanding. Make sure you understand if you're trying to find the measure of an inscribed angle, a central angle, an angle whose vertex is inside the circle, and angles whose vertex is outside the circle, okay? You also definitely need to know your parts of the circle. When you're looking at your segments, you need to be able to know or recognize if you're looking at 2 chords that are inside a circle, a secant and a tangent that have segments outside the circle, or 2 tangents, because that determines how you go about solving your problem. I hope this video helps. See y'all tomorrow for the test. Good luck.